All right, hello everybody. Today we're going to be going over another group of notes here just so you have more examples to kind of guide your thinking for the review sheet and your preparation for the test. So we're going to start by going through simplifying radicals because that's the first thing you're going to see on your test tomorrow. So you always want to start by kind of checking to see if the radicand is already a perfect square. So in the case of 64, 64 is the same thing as 8 times 8. So 64 is a perfect square. You'll also find that on your list, so my final answer here is just 8. Same thing for 196. 196 is a perfect square, so the square root of 196 is 14. This last one, on the other hand, you have to do a couple of things first. The square root of 80, because 80 is not a perfect square, needs to be simplified. 80 is the same thing as 16 times 5, which allows me to break this up into the square root of 16 times the square root of 5, and the square root of 16 is 4. Now in this case, you have the 4 that comes out of the radical and the 5 that remains inside because there are no more perfect squares that are going to help us simplify. Now this is the most important procedure in this entire test because every single problem could possibly be simplified. Now the next section you have to be worried about is adding and subtracting, starting with square root of 50 plus 5 square root of 2. We need to simplify the square root of 50 because that is the same thing as 25 times 2. Because 25 is a perfect square, I need to look for those opportunities. Now the square root of 25 is 5, so that comes out. And now I can finally add those coefficients. So I have 5 plus 5, which gives me 10, and the radical remains the same. So I have 10 square root of 2 for my final answer. Now this next one, I have square root of 27 minus the square root of 48. Both of these need to be simplified. Square root of 27 can be broken down into the square root of 9 times 3. The square root of 9 of which is 3. So simplifying that, I get 3 root 3. Now square root of 48 is the same thing as 16 times 3. And the square root of 16 is 4. So this problem, when I subtract 3 and 4, I get negative 1 square root 3. That 1 doesn't actually matter, so I get a final truly simplified answer of negative square root of 3. And that's that. So there are only going to be 2 of those on your test. Next section you're going to run into is multiplying. When you multiply radicals, you can multiply the 2 numbers outside or any number outside the radical, and you can multiply the radicand values, the numbers inside. So on this first one, 15 and 3 are both inside the radical, so I can multiply them, technically using this property to combine them. 15 times 3 is 45, and then I need to look for the opportunity to simplify. 45 has a perfect square of 9 as a factor, and the square root of 9 is 3. So my final simplified answer is 3 root 5. Next problem, I have numbers outside the radical that I can multiply. 3 times 5 is going to give me 15, and 8 times 6 is going to give me square root of 48. Now simplifying the square root of 48, I can break that into 16 times 3, and the square root of 16 is 4. Now that 15 that I had outside the whole time still needs to come into play here. So because now I have these 2 numbers outside, 15 and 4, I have to multiply those 2 numbers to give me 60 square root of 3. And that's that. Now this last one in multiplication, I have that outside exponent. I would encourage you to use that to write this power, this radical term, twice. So now this is exactly like the previous one. 2 times 2 is going to give me 4. Square root of 5 times square root of 5 is going to give me square root of 25. Now the square root of 25 is 5. The 4 does not change. So I now have to multiply 4 by 5 to give me a final answer of 20. So just because a problem started with a radical doesn't mean there's still going to be a radical when you're done. The next simplifying section I got for you is division, or rationalizing the denominator. So this first one, I have the square root of 9 over the square root of 100, both of which are perfect squares. So I'm going to get whole number parts here. The square root of 9 is going to give me 3. The square root of 100 is going to give me 10. Final answer, 3 over 10. Next one, I have a radical over an entire piece there. So I have the square root of 17 over 49, allowing me to split this up into the square root of 17 over the square root of 49. The square root of 17 will not simplify, as 17 is prime, but 49 is a perfect square. So the square root of 49 is going to give me 7. This is my final answer. This next problem, the square root of 5 over square root of 11, I have to rationalize by multiplying by a fancy form of 1. In this case, we have square root of 11 over square root of 11. Multiplying now is going to give me square root of 55 over square root of 121. Square root of 55 will not simplify, but square root of 121 is 11, which is the entire goal of rationalizing, trying to get that radical out of the denominator. We have to do the same exact thing on this last one, 9 over square root 7. My fancy form of 1 in this case is root 7 over root 7. Multiplying those, I get 9 square root 7 over square root of 49. The 9 root 7 is going to stay the same, and the square root of 49 is just going to be 7. And there you have it. Dividing and rationalizing. There will be 4 of those on your test. Now we're moving on to radical equations. There will be 5 of these on your test, one of which will have to be factored to find 2 solutions, or 2 possible solutions, I should say. But the others are going to be pretty basic answers of a single correct solution. Now the goal here is to always isolate the radical first in order to square both sides and eliminate the radical. On this first one, square root of x equals 7, the radical is already alone, so I'm going to square both sides, giving me x equals 49. And that's all there is to it, because there's nothing else under the radical to actually solve. Now, just to kind of confirm that, the square root of 49 is 7, so this one checks out. Now the next problem, I have to isolate the radical first, so I have to subtract 9 to give me the square root of n equals 4. Now I need to square both sides, giving me n equals 16. Confirm that answer by plugging it in. I get the square root of 16 plus 9 after that equals 13. The square root of 16 is 4. 4 plus 9 does in fact equal 13. So that one checks out as well. Now the last problem here, this is where you end up having 2 solutions, or 2 possible solutions. The radical is isolated, so I square both sides, leaving me with negative 8x plus 9 equals x squared. Now, because of that exponent, I need to get everything to the same side and factor what's left while everything's equal to 0. So I'm going to add 8x and subtract 9 from both sides to actually get my final equation here of x squared plus 8x minus 9 equals 0. Factoring this, I'm going to start working up here now. I have x plus 9 and x minus 1 equaling 0. And then you just kind of got to imagine this. I would have shorthanded this, but on video I will actually write it out. If I solve for the first factor, x plus 9 equals 0, I have to subtract 9, giving me x equals negative 9. But on the other one, when I have x minus 1 equals 0, adding 1 is going to give me x equals 1. Now, only one of these is going to work out. So, just to kind of show you this, the square root of negative 8 times negative 9 plus 9 is supposed to equal negative 9. The negative 8 times negative 9 is going to give me 72 plus 9, and 72 plus 9 is 81. The square root of 81 is which? 9, which is not equal to negative 9. So, x equals negative 9 is called an extraneous solution. We solve for it, but it doesn't actually work when you plug it in. Now, if I do it again using the 1, the square root of negative 8 times 1 plus 9 is equal to 1. Negative 8 times 1 is negative 8. Negative 8 plus 9 is 1. And the square root of 1 is 1. So this one does work out. So you definitely need to check your answers and kind of confirm whether or not your answers are correct. And those are radical equations. There will be 5 of those on your test. Again, one of them you will have to factor and find 2 solutions. Last 2 sections. One is Pythagorean theorem, the other is distance formula, both of which are extremely similar. Starting with Pythagorean theorem, a ladder that is 17 feet long is leaned against a wall so it reaches 15 feet up. How far away from the wall is the base of the ladder? So, this is creating a right triangle. Now, the thing everybody messes up is drawing the triangle and labeling it. It's always going to be a right triangle in this situation. Otherwise, we won't be able to solve it. The ladder is 17 feet long. The ladder is always going to be the diagonal length. So this is 17 feet. Now, the information in the problem says it reaches 15 feet up. Now, we're going to assume that's the wall. The wall naturally has to be straight up and down. So this distance right here is 15 feet. We are looking for this distance, x. So to solve that, the 17 has to be our c value. So I have x squared plus 15 squared is equal to 17 squared. Now I just have to isolate the x and make sure everything works out. So x squared is going to be added to 225. That's going to be equal to 289 once we simplify. Subtracting the 225, I'm going to get x squared equals 64. Taking the square root of both sides, I end up with x equals 8. So I end up with a whole number here. So my answer is simply a whole number. I don't have to worry about a radical or a decimal because it ended up a perfect answer. That will happen on your test from time to time, but you do have to look out for the possibility of simplifying a radical. Last section, distance formula. There will be 4 of these on the test as well. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So essentially all we got to do is plug those numbers in and see if they work. First one, x2 is going to be 13, x1 is going to be 8. So I have 13 minus 8, and that's going to be squared. y2 is going to be 5. So I have 5 here, subtracting negative 2. And when I subtract negative 2, subtracting a negative results in adding the same number. You add the opposite. So now I just need to simplify what I can. 13 minus 8 is going to give me 5. That will be squared on the next step. plus 7 squared. And everything is still in a radical. 5 squared is 25. 7 squared is 49. 25 plus 49 is going to give me 74. And good news, bad news, one, either way you think of it. 74 only has prime number factors. None of them are perfect squares. So I just need to find the decimal equivalent of the square root of 74, and that is 8.6. So my two answers, square root of 74 would be my radical, 8.6 would be my decimal. Do it again here for you. I have x2, which is 5, minus x1, which is negative 3. So I end up adding 3 minus a negative. You add the opposite. That will be squared. Then I'm adding negative 3 minus 7 squared. So simplifying, 5 plus 3 gives me 8. That will be squared. Negative 3 minus 7 is negative 10, which will be squared. Don't worry about the negative in this step because the squaring of the negative is going to make the negative go away. 8 squared is 64. Negative 10 squared is 100. 100 plus 64 is going to be 164. And this time, I definitely know there's a perfect square left in there, so we need to simplify that. Six, 164 is the same thing as 4 times 41. 4 is the perfect square factor in there. So when I simplify, the square root of 4 is 2. 41 is prime, so that's going to stay in there. The decimal answer is just going to be, type that in, 12.8 approximately. And there are your two answers. So again, simplified radical as well as the decimal when necessary. So that pretty much covers all of it. You just need to continue working on your review worksheet, continue working on the quizzes, the Delta Math, all of the different things that you have available to you. Just take the time to prepare and all will be well. Just come see me with any questions you have. There won't be a ton of time before school, but if you find me in between classes, I'd be happy to help you out. Anyway, good luck and we'll see you tomorrow. Thanks.